Thanks for joining me back here for another episode of Malware Analysis Fundamentals. Today we're going to be examining some dynamic analysis techniques, as I promised last week. Up to this point, we've only really been dealing in static analysis. So the primary difference there being that in static analysis, we don't actually execute any malicious code on our systems intentionally in order to study the behavior. We just look at sort of the metadata and the characteristics of the binary itself to see what we can gain or glean just from looking at that without actually executing the binary. So today, what I've got for us is a couple of tools. We're going to look first at Process Monitor, Wireshark, and we'll also be looking at how we can sort of boil those down into a very digestible format using a tool called ProcDot, which does operate on a couple of other tools in order to draw a large interactive graph that shows us everything that our malicious binary is doing in an easily digestible graph form. So we're going to go ahead and get started here today, and I'll get all of our tools opened up, get the sample on the desktop, and we'll get going. So the primary tool we're going to be using today is a tool called Process Monitor from Mark Risinovich's sysinternals. I don't really suppose it's his anymore since he works for Microsoft, but point stands. Process Monitor will basically monitor everything that happens on your system from a disk perspective, a registry perspective. I believe you can also set it up to do network. It's not quite as good at the network stuff. It's really good for file system stuff, as well as registry things, and just generally capturing behaviors like process injection or which processes handle on what, so on and so forth. So one thing that is important to keep in mind for utilizing a tool like Process Monitor is that it is very, very noisy, right? So you may not even be aware of this generally, but Windows does a ton of stuff in the background. It's always making changes to the registry. It's always getting handles on new files, new processes. Just constantly things are occurring in the background that are part of normal Windows behavior. So if I were to start this capturing right now, you can see that I've already captured 40, taking up too fast for me to even say, but we've already captured 100,000 events at this point. It's very noisy, and it can be a little difficult to tell exactly what's going on when you're running a malware sample if you don't know what you're looking for. Now, there are ways to filter this down a little bit, but because a malware sample may not behave in a way that's exactly predictable, you may miss things if you filter down on processes that maybe you're not expecting. So, maybe Excel spawns run-dll32.exe, which then spawns cmd.exe, which then, spawns an actual malicious binary that's strapped onto disk and local app data, something like that. But if you're not monitoring for each one of those specifically, then you're not necessarily going to know to look for them. So, unless you can monitor for inheritance, you're not really going to capture the full picture. So I think it's best to leave the filters to a minimum in Process Monitor. It's going to be a little bit noisier. It's going to take a little bit longer to sift through and see what you need. But I think ProcDot is going to help with that a little bit, which is why I'm going to show you that tool. Now, in order to use the output of Process Monitor with ProcDot, you do need to make a few configuration changes. I've already made those, so I'm not going to go through them in great detail. There are a couple of changes that you have to do with the columns here, including the process name, the PID, and the thread ID, as well as disabling some advanced output features. But what I'm going to do instead is down here in the description is going to be a link to a zip file that's going to contain a ProcMon configuration file. You can just import that using file import configuration, and that will make it compatible with ProcDot. So the primary tool we're going to be using today is a tool called Process Monitor from Mark Risinovich's sysinternals. I don't really suppose it's his anymore since he works for Microsoft, but point stands. Process Monitor will basically monitor everything that happens on your system from a disk perspective, a registry perspective. I believe you can also set it up to do network. It's not quite as good at the network stuff. It's really good for file system stuff, as well as registry things, and just generally capturing behaviors like process injection or which processes handle on what, so on and so forth. So One thing that is important to keep in mind for utilizing a tool like Process Monitor is that it is very, very noisy, right? So you may not even be aware of this generally, but Windows does a ton of stuff in the background. It's always making changes to the registry. It's always getting handles on new files, new processes. Just constantly, things are occurring in the background that are part of normal Windows behavior. So if I were to start this capturing right now, you can see that I've already captured 40, taking up too fast for me to even say, but we've already captured 100,000 events at this point. It's very noisy, and it can be a little difficult to tell exactly what's going on when you're running a malware sample if you don't know what you're looking for. Now, there are ways to filter this down a little bit, but because a malware sample may not behave in a way that's exactly predictable, you may miss things if you filter down on processes that maybe you're not expecting. So, maybe Excel spawns rundll32.exe, which then spawns cmd.exe, which then, spawns an actual malicious binary that's dropped onto disk and local app data, something like that. But if you're not monitoring for each one of those specifically, then you're not necessarily going to know to look for them. So, unless you can monitor for inheritance, you're not really going to capture the full picture. So I think it's best to leave the filters to a minimum in Process Monitor. It's going to be a little bit noisier. It's going to take a little bit longer to sift through and see what you need. But I think ProcDot is going to help with that a little bit, which is why I'm going to show you that tool. Now, in order to use the output of Process Monitor with ProcDot, you do need to make a few configuration changes. I've already made those, so I'm not going to go through them in great detail. There are a couple of changes that you have to do with the columns here, including the process name, the PID, and the thread ID, as well as disabling some advanced output features. But what I'm going to do instead is down here in the description is going to be a link to a zip file that's going to contain a ProcMon configuration file. You can just import that using file import configuration, and that will make it compatible with ProcDot. Okay, so let's take a look at ProcDot real quick. When you open it, this is the first screen that you will see. It's going to tell you that there are some third-party components that you have to have that it does not come with. Those will be GraphViz or .exe, which is GraphViz. And also you can utilize WinDump that will allow it to better utilize networking information that you pointed to. So I've already got mine pointed to GraphViz. I'll go ahead and get it pointed to my WinDump as well. You will have to perform this step manually. I will provide in the folder the ProcDot binaries that you're going to require. However, you will need to actually point it to wherever you extract those, just so that it's aware of where those binaries live on your specific system, since obviously they won't be the same as mine. Once you do that, you can actually point it to a ProcMon and a WinDump or Wireshark log. It can handle both WinPcap as well as WinDump.txt files. So it can handle PCAPs, it can handle just regular text output. But today we're going to be using Wireshark instead of WinDump. Hopefully that works. I think it works pretty well. If not, we can just look at Wireshark and get our information from there. But again, this tool is going to be great for taking that ProcMon output and just displaying it in a nice clean graph here where this black square is. So the next step for us is going to be to actually start monitoring and looking at what we've got going on. I've got a sample of a dropper here. This is a dropper for the malware family Dridex. So what we're going to do is we're going to start monitoring with Process Monitor. I'm going to open up the sample, enable the macros, let it run wild for about 5 to 10 minutes, and we'll just sort of see what happens. I'll also leave Process Hacker up, and I'll be taking a look at that just to make sure that we're running properly. I'll probably leave the screen recording, and just so you guys can see exactly what's going on, we'll speed through it a little more quickly. But it's important to remember that it's good to let these kinds of things run, because a common tool that adversaries use is to put in things like long sleeps. So, you may enable macros and it might not do anything for 5-10 minutes. And the reason for that is they want you to be impatient. They want to impede your analysis of this document. And so they want you to think that if it doesn't do anything for the first 5 minutes, maybe it doesn't do anything at all. Maybe they made a mistake in their dropper. Maybe their dropper doesn't work like it's supposed to. And so they just want you to stop analyzing it, right? Another reason for that is to bypass automated analysis. So a lot of ephemeral sandboxes like Cuckoo or any.run, things like that, may only run for 45 seconds, right? So if it's only running for 45 seconds and I want my malicious program to sleep for 46, well, the sandbox isn't really going to detect much. So it's to evade analysis by an impatient SOC analyst, and it's also mostly to evade analysis by automated sandboxing utilities like any.run, hybrid analysis, things like that. A lot of those have gotten quite good at detecting those long sleeps, so that may be something that's going on there. It may be a little less effective than it used to be, but it is still something that is important to keep in mind. So let's go ahead and get the sample open. We'll start monitoring right now. So starter up on Ethernet 0. It's going to prompt me for this. All right, and we are capturing on Wireshark. And we are capturing on ProcMon. Go ahead and open up Process Hacker here. Just to be watching that in the background. Make sure we're getting some behaviors. And let's open up Excel. All right, gonna launch here. Doesn't seem to like the extension of the file. We'll change it to XLS. I downloaded this from Malware Bazaar, which is a great place to get malware samples, but it seems like sometimes the extensions aren't quite correct. So we'll go ahead and open this as XLS, which seems to be more agreeable. Yeah, okay. So nice PWC themed fish here. Yeah, I'll accept your license agreement, that's fine. And we'll just enable those macros because we love macros. Macros are great. All right, perfect. So it looks like we've got Excel running. I imagine there's a couple of processes running in the background now that we've enabled that macro. So I'm just going to let this keep running, and we'll come back and see what exactly has happened. Okay, so at this point, you watched as the behavior sort of rolled by here through our different tools. Process hacker, not necessary, but it does give you a good idea of things that are going on in the background. Um, you probably saw about 5 minutes in where a mixed cased command prompt non hidden window popped up and appeared to spawn a PowerShell window as well that was hidden. So, pretty good indicator that we've probably caught some pretty shady stuff going on. We captured approximately 45,000 network packets and well over a million events on Windows. Now, we can filter some of that down. For instance, we can get rid of things like Wireshark. We are already excluding Process Monitor. We can also exclude Process Hacker. So the way that we can do that is we'll just say process name is not actually we'll do is wireshark.exe, then exclude. We can also exclude dumpcap.exe, apply. Better add that first. Let's see if there are any other ones we can get rid of. Let's get rid of vmtoolsd.exe. Not going to be important to be looking at that. Just scrolling through here. There are ones that you obviously want to keep, like svc host or wmi perv se. That can be used for some fairly malicious stuff. So good to have those in there. We'll go ahead and just apply this. I think that's going to be enough. It'll take a minute to apply because obviously we have 1.2 million events that we've captured. So going to run through here, filter some of those out. Perfect. We cut out about process hacker. Yeah, let's add that one too. Process hacker.exe, then exclude. We've cut down about 200,000 events so far. Looks like we've got a PowerShell process here that has become apparent to us now. That may be housing some malicious behavior. Say okay. Looks like we've cut down another couple 100,000 events. I think we're going to want to keep the rest of these. Yeah. Yep, we'll keep the rest of these. And what we're going to do is we're actually just going to save this. So we will save what we have captured. Now you will want to save this in a comma separated value, the CSV. That is what ProcDot accepts. So we will just save that to our desktop. We'll call it logfile.csv. That's just fine. We'll export that. Now that's going to take some time to export just because we have, nearly a million file system events that we want to take a look at. So we'll just let that export. And while we're doing that, we'll go ahead and take a look at some of what we've captured in Wireshark. Now, we'll take a closer look at this in a little bit, I think, utilizing ProcDot, assuming it's agreeable. But one thing that I've found that is actually very useful, not always, but a lot of the time, is to just start out by looking at DNS events. So udp.port equals 53, which is the port that DNS runs on. So we can just take a look back through here at any of the lookups that processes on this host has done. So it looks like we looked up oneclient.sfx.ms. That's probably just Microsoft related traffic. msn.com, live.com, pretty normal stuff. Chrome, Cloudflare, probably good stuff. Now this one's a little interesting. otr.virtualexpose.in doesn't ring a bell. Don't know anything about that. That's probably going to be related to the malware if I had to guess. It may not be, but it's certainly suspicious enough for me to take a look at it. Now, here's some interesting stuff. It looks like we're looking for 2.0.0, right? Some very long names here. I'm not sure, but that could be indicative of something. Looking up random DNS pointers to see if DNS is lying to it. So another thing that may be indicative of some malicious activity there. Gotta keep scrolling up. I haven't seen anything jumping out at me quite yet. You can see my iPhone, my wife's iPhone on here. because this is on a bridge network right now. Skype, that's interesting as well. That could again be nothing. Some Spotify stuff sounds about right. Let's scroll all the way to the top here. wj32.org. Interesting. Wife's MacBook. My Google Home. All kinds of good stuff in here. What we'll have to do, I think, is just import this and see if we can spot anything within ProcDot that either points us back here, or if there are just some suspicious network traffics that take place from our Excel spawned processes, which they're going to be, I'm almost certain, that are also reflected within our Wireshark log. So what we'll do now is we will just go ahead and save this file. We're going to save this as a pcap, not a pcap-ng, and we will just save it to the desktop, and we'll just call it dridex.pcap, because why not? It's dridex, it's pcap, dridex.pcap. So now we'll just wait on this to finish exporting. We'll come back and load it into ProcDot and see what we're left with. Okay, so at this point we have finally exported our massive log of Windows events. We've also exported our dridex pcap. So now all we need to do is load those into ProcDot. So what we'll do is we'll go and click this little ellipsis here and point that to our log file.csv, which is 171 megabytes. So we'll get that loaded in. We will also point it to our dridex.pcap, and we will then click this little ellipsis here, which tells ProcDot which process to actually start with. So that's going to be the base of the tree, and then it's going to look at everything that's got an ancestry. I made a reference to that earlier and did not adequately explain it. Everything that has an ancestry, that is to say it's either a parent process, grandparent process, or so on, of the original Excel process that launched the macro. Now, there are ways that threat actors may hide this, and we may have to look into that as we dig further into this dynamic analysis. But that is how it works, and it's a good way of looking at processes like that, just seeing what ancestry the process has, so you can kind of infer whether or not it's a malicious process based on which process created it. So let's go ahead and do that. It's going to take a second to load through the ProcMon file here just because it's so large, so we'll give it a moment to do that, and then I'll meet you back here once we can actually select which process it is. Okay. So we have loaded it in there, parsed the file. We can now select our parent process here. I'm not sure which Excel it actually is. Looks like we've got a couple of them, but we'll just really have to do some experimentation. Looks like we've got DLL hosts, some cmd.exe stuff, as well as consent.exe, which is normally OSC stuff. We've also got looks like PowerShell, which is going to probably be bad, and then schtasks.exe as well, which could indicate perhaps a persistence mechanism. So what we'll do is we'll actually just go to the excel.exe with the lowest PID first. So hopefully that will be the one that we're looking for. So we'll just select that one. Now that we've selected our process, all we have to do is click refresh, and it will start drawing the graph for us. So it's probably going to take it a minute to draw this graph just because of the large amount of data within the file that we have. So I'll give this a minute to draw that graph, and then when we come back, we'll examine what data we have to parse through. Okay, so at this point, we have run our sample of dridex. I've captured its network traffic with dridex.pcap and logfile.csv, and I have selected the launcher up here, but I've actually run this in dumb mode. So in ProcDot, if you run something in dumb mode, it doesn't attempt to infer anything by parent process. It's just going to show you basically everything that happened over the course of the execution that you captured within process monitor. So what we're going to do is I'm just going to go through this a little bit, and as you can see, it's kind of spaghetti right now, and part of that is due to the fact that we've run it in dumb mode, and the other part is due to the way that ProcMon runs, is due to the way that DryDex runs. It's a fairly complex piece of malware that uses many sets of obfuscation techniques in order to avoid analysis by analysts. So what we'll do is we'll just dive right into this and start taking a look at what exactly happened. So first thing, we can see the Excel process up here, which is really doing quite a lot. So let's just zoom into this graph here and we'll start looking at some processes. So our first one here, looks like we've got wmic.exe, so some WMI reconnaissance perhaps, some mishta.exe, so perhaps we are dropping some files utilizing some malicious calls to web servers. So those two stand out to me just immediately. Here we've got our Excel process. So let's examine our Excel process. Unfortunately, Excel's quite noisy. So with any Microsoft Office program, they tend to be quite noisy and do a lot of things in the background that maybe we're not necessarily aware of that are not inherently malicious. I find one of the best ways to view this, though, is to start actually looking at the ends and then work your way backwards from there, because that's going to give you a good idea of if anything malicious took place during execution, just by looking at these endpoints here and then working your way backwards. So let's see. Nothing here. What we got here? Again, nothing. As I said, very noisy program, so it does take quite a bit of time to sort of filter through that. And it's really not helped by the fact that DryDex is a particularly complex piece of malware that's going to perform a lot of different actions here. I think here we can start to see some rather nasty stuff going on. Okay, so this is near the Excel process and has several branches going back to it, it looks like. We can see a DLL written here. Looks like that was run DLL, called that DLL. Let's just zoom in onto this. So run DLL with PID 3000 loaded this DLL. So that is possibly a good indicator there. We can go and check and see if that's still on disk. It may not be. They may have renamed it at this point. So we'll scroll back and just start working our way backwards. Looks like run DLL again was the parent process of that with a different PID. Looks like we have con host here, which is going to be related to a console window spawning. Keep going back, looks like more con host, which may be, something like PowerShell or command prompt. So we've got PIDs 5576, and that was spawned by WMIC. So that's pretty common. What you'll see with things like this is that they avoid running PowerShell directly under Excel because that is quite suspicious and triggers a lot of EDR things. So what they'll do instead is do what's called indirect command execution, and they'll use WMI to make a call to PowerShell and then execute their malicious payload, so that you don't have that relationship of Excel, PowerShell, run DLL32 that's going to light up the EDR like a Christmas tree. Now, a good EDR is going to be able to correlate that anyway, but a bad one won't. And same goes for an analyst. A bad analyst won't be able to. So if we go back to WMIC and then go up, looks like that was spawned by a mishta PID. Mishta is mshta.exe, so that it can execute HTA files, which are basically just a methodology of getting a malicious script to execute. You can also open malicious websites, things like that, but generally a malicious script of some variety. So obviously in the dumb mode, we get the most amount of information possible, but it also becomes a little difficult to parse through just due to the amount of data that we're being presented with. So what we can do is we can look at the actual parent process, excel.exe. Or what we could do instead to try and pare this down even further is we could look at some processes that are suspicious to us, right? And these will kind of come with time, and you'll be able to recognize what's not normal. But things that really stand out are going to be things like rundll32.exe. That's not really something that you're going to see spawned particularly often. I mean, it is built into the Windows operating system, and Windows does use it for legitimate purposes. But if I'm capturing a 5-minute snippet when I know I'm opening a malicious sample, rundll32 is probably involved in that. We can also take a look at wmic.exe. That's often used for proxying execution, as I said. So we're taking that and breaking that parent process that's going to light up the EDR by calling WMIC first, using Windows Management Instrumentation to sort of break that relationship. We can also look at mishta.exe, which is, again, going to be highly suspicious anytime you see that. So first, we will just start with mishta and take a look and see if anything stands out to us there. All right, so we've got the graph generated for mishta. Let's just zoom into the parent process here and see what we can see. So it looks like it created 2 threads and 2 processes. Mishta then created a wmic.exe process. So we know where wmic is now. Got another process here, which looks like it wrote lightvertical.xsl under program data. So that will be an interesting file to check out. Let's get IOC. We know that that's going to be there. Keep on going down this way. Looks like an auto start key. You get a lot of these that may or may not be false positives. It's definitely something worth looking into, but I wouldn't be too concerned about that. Looks like we have a temporary DLL written to the internet cache. So that's certainly interesting. That's probably their payload that they're going to inject. Looks like we've got rundll32 being spawned from wmic as well. And that is being run from cwindows temp. So again, another good DLL to check out there. We're getting some good file IOCs here. Looks like some inet zone stuff here, which is probably going to be related to mishta being used, I would guess, to download that malicious payload and write those 2 DLLs. So, okay, with mishta, we've looked at this process. We don't really need to look at wmic now, I don't think, unless it's a different PID, because we know that mishta was the parent process of it. So 1492, let's keep that in the back of our mind while we go and see what other processes we can look at. So we'll go ahead and open that up, and we will wait on ProcMon to get us a list, and then we'll take a look and see what other processes we might want to look at. Okay, so looking at the list, it looks like mishta was basically responsible for generating basically everything else that we saw. So probably not going to be particularly helpful to look at that one. We can, however, look in the context of excel.exe and see if there's anything else interesting there that we may have missed that happened before mishta was spawned. So we'll go ahead and load that one up and just take another cursory glance, and then we can basically jot down all of the IOCs that we've collected here and examine those further. So ProcDot really helps to sort of generate this interactive graph and understand sort of the parent-child relationship of what exactly occurred during an infection. So we'll generate this graph, and I'll meet you back here, and we'll take a look at anything else we may have missed before the execution of mishta. Okay, so we've got our graph generated for Excel here, and on the basis of Excel, I don't really see anything of particular importance that we've missed before the execution of mishta via wmic. And if we scroll down here, we can see some of those processes again with the rundll32 happening as well, concurrent with Excel, and then Excel having some threads on it and things like that, including this lightvertical.xsl. However, there is something I want to draw your attention to, and that is going to be an SVC host process down here, reaching out to 172.16.143.1 and 2 addresses, which is kind of interesting. But the really important thing that I want to look at is actually up here. We can take a look at another SVC host process, a PID here that spawned a child PID, which is pretty normal behavior. But what you'll see is some scheduled task information.
So if you take a look at these, you can see HKLM, software, Microsoft Windows, blah, 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 and then updates, 2021 updates is in there as well. So those could be some quite interesting scheduled tasks that are being utilized by persistence from the malware author here. So what we can do is we can actually just go check those out really quick to see if they're even related, because they don't appear to be part of the tree, but Dridex is a tricky piece of malware that uses a lot of process injection and things like that. So it may be worth our time to actually go see if those are related. It is a little bit odd for SBC host to be randomly creating these tests at the same time that our malware was executed. It's also fairly odd for a task named as such to be created. 2021 updates does not really seem like something that is legitimate, just based on my personal experience. So we can actually just go take a look at those. And for that, we'll just use PowerShell. Open that as administrator here. Wait on that to open. Not sure why PowerShell takes quite as long to open as it does sometimes. So we'll ls tasks. And sure enough, we've got 2021 updates here. So we will just cat 2021 updates. Okay, so we can take a look here at the task to run that is set. And you'll see that we have some very suspicious arguments here. So mishta, and then VB script execute. And it's going to create a shell object, and it's going to run some reconnaissance commands, it looks like. It's going to look at something in the all users profile. So expand environment strings, and then it's going to run qlightvertical.xsl. So that is the persistence mechanism for this particular sample of Dridex, it would seem. That is going to spawn that mishta process every time, which is going to spawn that wmake process, which is going to spawn that run DLL32 process. So we have found basically the chain there that Dridex executes along, and then also tied that into the persistence mechanism that it created utilizing SVC host to do so. Okay, I realize this is a lot of information. It's quite complex, particularly with this malware sample. So with that said, what I'd like to do is kind of take a step back a little bit, take a look at another sample that's hopefully going to be a little bit more simple, and sort of show you the power of this. I really wanted to show you the Dridex sample because it really blows up ProcDot and gives you a lot of information that you can go through. It is very time consuming. I've sort of pared it down here. Otherwise, we would be here all day just parsing through this stuff. I parsed through it beforehand just so I could highlight some things that I wanted to show you. But again, very complex. So let's take a step back. Let's look at another sample, and hopefully that'll make things a little bit more clear. All right, so what I've done is I've obtained another sample. This time we are working with TrickBot instead of Dridex. And really what I've done here is I've just run through the same process that we've already done with this nice little DocuSign themed fish. I've opened that, enabled macros, and monitored it and generated a graph for us. The reason I wanted to show you this is because malware samples are not all created equal, and some are a little more tricky than others. So in this case, we have a very clean cut graph. If you scroll out, there is not a whole lot to it. It's not like the spaghetti that we saw last time. If you take a look, we've got the Excel process, and then created PID, which then creates 3 different Reg Server 32 processes. The other reason it created this many is because it appears that the C2 is down for this sample, and it wasn't able to write out its payload. However, as you can see, there's no proxying of execution here. It's directly Word or Excel rather to Reg Server 32, and then all of the processes which attempt to execute the malicious payload that it tried to download. And you can actually, additionally, within here, right-click on one of these processes and look at the details, and you can see that it's attempting to run something called kro.fis1, which is almost certainly going to be a DLL. That's just how Reg Server 32 works. You point it to a DLL. So it was attempting to execute a malicious DLL. Unfortunately, it couldn't download that. So that is what we're left with. So if we zoom back out of this view here, you can also see that we've got several calls to different IP addresses here, including a wpad.local domain. And none of these are particularly interesting just because of the nature of the C2 being down. However, I did want to highlight the ability of ProcDot to actually take a look at each one of these, and you can right-click any IP address that was seen within the execution flow, and you can just say open packets in Wireshark, right? And then it's going to open the associated PCAP and then give you the full TCP sort of stream here that is associated with that IP address. So it'll sort of carve that out a little bit so you don't have to do that yourself. You can also just right-click and click Follow TCP Stream, which will stay within ProcDot, and it will show you the TCP flow of traffic between that IP and another. Let's find one that's going to work here. And you can see it's just meaningless data in this instance because it was over HTTPS. We can't read that. You could eventually if you did something like import a key. We'll go over that at a later date, being able to capture and decrypt HTTPS C2 traffic. That's pretty handy to be able to do that, not particularly difficult. But as you can see, ProcDot is a very valuable tool, and it can show you, the association of that parent process with the child process that's malicious, and it can give you a more clear picture of everything the malware did on the machine while it was running. All right, so a quick recap of what we went through today. First, we configured ProcMon and Wireshark to be compatible with ProcDot, and then we took a look at how we could execute samples of malware, capturing their traffic and their behaviors within ProcMon, export those, import them into ProcDot, and then examine the way that they behave in a graphical nature to sort of make things a little more simple to parse through than looking through the table that is ProcMon itself. Really what this tool helps us do is visually establish those parent-child relationships between processes to really understand what it is that a piece of malware is doing as we execute it on the machine, and sort of help us collect those indicators of compromise that may lead us to binary samples or perhaps network resources that we can examine closer in more detail and perform more static and dynamic analysis on those binaries that it grabs. Or other binaries that it writes or injects or things of that nature. So this really just helps us to understand what path the malware is taking to execute its payload and sort of do whatever it is that the threat actor has intended for the malware to do on our systems. I hope today's video has been helpful for you. I know it may feel like a lot of information and perhaps a little bit disjointed. It kind of was a little disjointed. I was in an accident this past week where I broke my wrist, so it kind of prevented me from making any videos for a while. So I had to catch up between weeks. It was a little difficult. But nevertheless, I hope this was helpful, and I hope it helps you out. Let me know if it did or not. Down there in the link in the description, you'll be able to find all of the samples that I used for this, as well as the tooling and the ProcDot configuration files. So take a look at those and give this a try for yourself. I hope this does make you a more effective malware analyst, and I will catch you soon.